Today we're going to be sitting down with Nate Higgins, plant manager at Alpha Precision Group. APG is an early customer for the studio system, and they've been printing with it for the past few months. So over that time, they've printed a whole bunch of parts. Nate's going to share a little bit about how they use the system at APG, show off some of the parts that they've printed, and what impact it's had on their business. So Nate, start off, can you tell us a little bit about APG, what you guys do, who you guys are?
Yeah, thanks, Nick. APG is a company that's been in the captive or the contract manufacturing of metal components for over 50 years now. It started with Alpha Sintered Metals. Alpha Sintered Metals is a manufacturing of conventional press and sinter technology, specializing in high-density stainless steel applications. Those high-density stainless steel applications is what then drove the business to start looking at metal injection molding. So I'm the plant manager of the metal injection molding facility. And at this metal injection molding facility is where we're starting to look at additive manufacturing. So with our expertise in sintering, we also have a location that does variable valve timing components. So it's another sintered metals technology. And then APG also has a location that specializes in machining and assembly. And that location's in Michigan.
Awesome. So you talked about you guys do MIM already, right? So you do a metal injection molding. So what was the kind of impetus for you guys to actually go out and look at and eventually purchase a metal 3D printing solution?
Yeah, I mean, at times we have components where we're not able to manufacture them with any of our technologies. So we really wanted to be able to grow that technology portfolio and offer something different to our customers. We understand the incoming material, powder morphology, metallurgy. We have a very good understanding and expertise here. We have an expertise in the back end of it, the sintering side. So this is where this technology made perfect sense for us. We're familiar with 3D printing on a plastic scale and being able to use this for internal applications. And that's why the studio system made a lot of sense for us. We said if we can tie some value adds to internal applications, also benchmark the technology, see if it works in our high temp sintering capacity that we have, and it makes sense to grow the business that way, it's something that we wanted involved in. And we've had the printer since August, and it's been hugely successful for some internal applications.
Awesome. So when did you actually start taking a look into metal 3D printing technologies, and kind of what was the view to end up on binder jet and VMD?
Yeah, so we really started our dive into metal 3D printing in about 2016. We looked at some of the powder bed fusion technologies, and we were pretty serious about moving forward with some of the DMLS options, and it just didn't make sense for our specific case. We wanted to be able to do something that leveraged like our current expertise, like I said. And powder bed fusion is an entirely different technology that we would have to learn from, from the incoming powder to the finished part. And it didn't really have a technology that would leverage what we're currently doing. So that's why when we started that investigation, we looked at a bunch of different other companies. What you're doing at Desktop Metal made sense for us. The binder jet technology, that makes sense for us because it's a powder system, and you also have to sinter it. And that sintering piece is what really tied us to. Like I said, we have a large installation of high temperature sintering. We're able to use that and really grow and have a niche that we can tie to, and we can help push the technology and tweak the technology in our own way.
Awesome. So it sounds like you've been using the Desktop Metal system quite a bit since you got it in August. So how many parts would you say you've run through it so far?
We've been right around 200 parts that we've ran. Not 200 individual pieces. We've had to reprint some parts and make some changes, but in total about 200 parts.
Awesome. So I see we brought a few of those here today. So can you talk a little more specifically about some of the applications you're printing with the Desktop Metal system, and then talk a little bit about these parts you brought in?
Yeah, so something that we did with 4 locations is we went to all of our engineering groups and we said, our process is fairly long. We go from powder to a molded part, a green part, and then we have to follow through a number of different steps, a sintered part, and then a machine, and we also do internal machining. So there's a lot of different gates there where we could use internal applications on our own. So for some of these, most of these are MIM applications. One's a conventional press and sinter, but so this application in particular. So this is a MIM application. Something that's probably not talked about a whole lot in MIM is having to do coining. Sizing a feature would be what it would be called in conventional press and sinter. So any tolerances that you're not able to achieve through the standard process, you depend on the elongation of the material, and you're able to hit it and get it back into the tolerance that you need. So this is an application that we did where we realized, during the launch that we weren't able to get to the tolerance of a specific feature. We came up with a design, we printed it, and in 3 days we were able to have a functional coining fixture that we were able to put a part in, coin the parts, and continue in the launch cycle. So that was a huge application for us. This application is a custom air knife. So this is something that I think has more potential as we continue to grow. But traditionally we just use a standard air knife for the Venturi, and it blows air on the parts and blows powder off the parts. This is something that we're now able to customize and make custom geometries to parts to more efficiently, use specific part applications.
And so there's two things I want to point about this one. So that actually has internal channels running through the part.
Correct.
And that, can you talk a little bit about how that would work in the application it's being used for?
Yeah, so this has an internal channel down here and then a bunch of small holes, which you probably can't see. But this is just something that allows us, instead of just traditionally with drilling a straight hole and capping it, we're now able to have all internal plumbing throughout the part. Something that you're not able to do with traditional manufacturing methods, and you're able to get custom radiuses like this that you wouldn't be able to do. So it really opened up the possibility of what we can do in our process.
Awesome.
This application here is for 100% thread check that we use. The thread check is used on our conventional side. So for high density stainless steel applications, one of the large applications is in sensor bosses. So a sensor boss is then welded onto the side of an exhaust, and such like your O2 sensor will go into that. Critical to that function is that the thread is present in that. So we thread all those internally, and then we run them through 100% thread gauge. And this part is pushing that into the side of the gauge to align the part and then be able to check the thread. It's a wear item. So this from the manufacturer costs about $600. And we're able to print this, machine a couple features, do some cleanup for under $100. So it's over a $500 savings, and we don't have to wait for these parts from the manufacturer. We're able to make the solid model, put it on our machine, have some in inventory, and keep the line running at all times.
So I think that's an important point to bring up. So what does this have an impact on as far as lead time for your tooling applications, things like that?
Yeah, I mean, we have our own internal tool shop, which we utilize a lot. I mean, our tool shop is full internally, but there's still a lead time. Although we have that internally, there's times that it takes 4 to 6 weeks to get something through the shop. We're able to print things like this in days. So we're able to condense that down from weeks, sometimes months, to days, and that's absolutely critical.
What's the last one we got here?
Yeah, so this application is for our vertical mills. So at MIM, we do our own vertical CNC machining, and one thing that we do, because we're so flexible in what we do, we use cap head screws to tighten a lot of our parts into the assemblies and into the fixtures, and it's a large drain on the time that it takes for changeovers in between parts, because our operator has to actually loosen all those, pull the parts out, and it takes a lot of time. It's labor intensive. So we came up with a design that can we loosen the bolts and tighten the bolts on the other side without having to do that manual piece. So improved time to change over parts, decreased cycle times. It's a huge potential if we were able to figure it out. So what we did is we came up with, one of our CNC engineers came up with a design, and we said, I think that works, and looked at machining some of the components, and we said, well, let's see if we can print them, if it has tight enough tolerance to do that. So we were able to print everything here, and in this housing there's a ratchet assembly. So just like the end of a screwdriver, it ratchets when it's tight enough. So that's key. So we're not over torquing or under torquing. And then in the end here is really where the most of the problem that we had when we were launching. We realized once you set on top of the cap head screw, you have to have downward pressure in order to get it into the actual socket. So what this does, it has a spring located inside of it, and we're able to push down and then turn it and make sure it seats well inside there. These are two components which would have, again, taken weeks to machine, and we were able to do this entire iteration in under a week. So all the way from concept to using in production and making sure the design worked in under a week. The cost savings on this is huge. We have 5 machines now that a single operator is able to run because of this. It's been a great application for us.
Awesome. So for everybody watching, if you have particular questions on these parts or anything that Nate has been talking about so far, feel free to drop them in the comments, and we will get to them at the end of the webinar. So Nate, talked a little bit about all these applications, and obviously we can see kind of the finish on some of these parts right here. But what has the quality of the parts, how has that turned out for you guys? Is it up to spec for what you need it for? And what kind of learnings have you had around that?
So there's really 2 different areas that we've used the parts in. We've tried to do some customer applications where it's R&D, early launch work, where we're able to get a customer a part in hand in a week. And we've done that. We've shipped parts to customers, and they're able to get them into their assembly, but there's typically something that doesn't work. It's either surface finish or a very tightly toleranced hole, and we're able to clean that up with machining. So the big thing that's learning for us is where do we need a secondary operation, working with our customer to understand critical features so we can clean those up before. But I think on that early launch side, there's a huge potential. So tolerance is there. We're still learning. It's really growing with the customer and realizing that it might not be a perfect replica of what they're going to see in production, but at least get some apart in hand. So that's something that we're continue to have success with, and I think as we further the technology and as we work with the customers, we'll have that. But for the internal use cases, such as coining fixtures and different jigs and fixtures, we've had huge success because we're controlling it. We know what's critical. We know if we can machine certain features if we have to. But all these applications here, we hadn't machined anything. We cleaned up some surface finish in here just to allow for that sliding, and we put a thread in this component here. But other than that, the tolerances have worked out fine.
Awesome. And then what about from a metallurgy perspective? Are they meeting what you're typically seeing from other processes? Yeah.
So really, what we wanted this to do is replicate some of the MIM metallurgy that we would see. And early on when we were printing parts, we were mainly printing parts to cut them, get them to our metallurgists, and make sure we were getting structurally sound parts. And we were very surprised. The hardness, the densities, when you're looking at cross section, are pretty much in line with what we would expect from MIM. This part in particular, we were worried about the wear because it is 17.4 right now. But we were able to heat treat it, get it to a hardness in the high 30s, and it's held up great in assembly.
Awesome. So seems like you've been doing a lot of printing since you got your studio system, obviously. And how have you been able to actually integrate that into your workflow as a business, right? We all know that adding a new machine is not the easiest thing in the world. Mm-hmm. How has the studio system been for that for you?
Yeah, I mean, the biggest piece is the Fabricate software is extremely user-friendly. So we're able to grab engineers, show them the Fabricate software, and they can print freely. Like I said, we have some other printers, so we're familiar with similar with software, but it's really a design software. I mean, you drop a model in, it gives you a rough iteration of the supports, and you send it to the printer. And then we've worked pretty closely with a lot of the AEs, and trying to make some slight changes. So on the printer side, process flow, it has absolutely dropped in flawlessly. As always, the network and the cloud base is a little bit of a hassle with just IT departments and having to work through that, but that's been pretty flawless also. And then the debinder, the debinder bin's great. For us internally, we use catalytic debind. So the solvent's something a little different for us. We're familiar with it, but we didn't have any solvent units, so we had to depend pretty heavily on your unit, and it works great. Again, it's extremely user-friendly, no programs to worry about. You just select the parts and drop them in. And then the furnace. The furnace, we've done the same thing. We've sintered some parts, checked the structure, and then sintered alongside some parts in our more production furnaces. And side by side, the structures are both acceptable and comparable.
Awesome. So at the end of the day, kind of wrapping it all up, what would you say the impact of the studio system has been on your business as a whole, right? You talk a lot about the lead times, you talk about part savings, like how does that all kind of come together to develop some sort of, maybe it's an ROI or an increased efficiency for your company?
Yeah, with any piece of equipment that we purchase, we're looking to tie an ROI to it. And with these applications, we've been able to tie an ROI to it. And we'll continue to grow this. It's been a huge cost savings on just a few applications that we've done. And as we do more, we'll learn from that. So it's been absolutely huge in terms of a cost savings.
Awesome. So we'll flip it over to a few questions. So we will hop into the YouTube, and if anybody has any more questions, anything from integrating into the business process to specifics on the parts, please feel free to drop it into the questions there. So one question we have here on the third part, so I think we're talking about this guy. How long, do you have any idea on the time it took to print that part?
I don't know that one off the top of my head. I think that was like a 6 to 8 hour print somewhere in there.
I think that's typically what we see. Stuff about this size, a half a day to a full day, depending on some of the different ways that it goes. But definitely probably quicker than some other processes you would be making that from. Another question. So can you talk a little bit about, and if you know a little bit about how the printer is actually printing these internal channels, as far as, actually kind of can't really see it on the camera, but you can see the layer lines here. So the question is, what type of printer is used for the internal channel part? So that was printed straight off the studio system, right? Yeah,
printed straight off the studio system, and this is actually the first part which I worked with the AEs closely on, because I knew we were going to have some support in some areas, and we were able to tip this in an orientation where we were able to print all the internal plumbing without any support features.
Awesome, that's very cool. Yeah, and can you talk a little bit, just in case some people aren't familiar with what the support features would do, can you talk a little bit about why that's an advantage of being able to print it without the support features in the middle?
So the support features are there to support any geometries that are going to move during sintering. So you're so close to the liquid phase during sintering that you're inherently going to potentially cause some distortion. And any areas that aren't flat on the ceramic or supported well are going to distort. So the support features are there to help with that distorting and catch the part. But if we can turn those off in sometimes where the software might predict that you're going to need something, and then see it in real life, whether it held up in sintering, it's huge. And in the software, you're able to very well manipulate the support features.
Awesome. So another question I have here, have you evaluated 3D printing for a small serial production, so say a few hundreds of pieces, and what are some of the pros and cons of doing that?
We have, and I think there's absolutely a place for this as it continues to grow for that small serial. But really what we're excited about is the production system. And I don't know if that's a good time to talk about that or not,
sure.
But I think that's where the production system is going to fit best for us, and what we're excited for is, in the bell curve of a product launch, you have that early launch phase, you have the full production phase, and then you have the aftermarket. And those few hundred pieces a lot of times fall in an area where contract manufacturers don't serve very well. But we want to be able to serve that. We have a team of engineers, and we want to be in those R&D phases. We want to be helping design parts for production that are going to launch flawlessly into production. And the production system is going to be able to do that. I think for certain applications, the studio system absolutely can. So in our build-up, we have studio system technology. We have a low-volume bridge to production tooling for MIM that we're also looking at some applications for studio system. And then we have the production system, wherever that fits in. And then we have MIM and conventional press and sinter and machining. So I think for those low volumes, it's going to be a combination of, depending on the part geometry, the studio system absolutely has a place. I think quick turn tooling on MIM has a place, and I think the production system has an even larger place.
So I have one question here, if we can show the parts a bit closer. Unfortunately, we cannot during the live stream, but what we will do is send out a deck with each of these parts, some information about them, and some close-up photos of them, so you can get a real close look, kind of see some cost comparisons and that kind of stuff. Another question I have here, this is something we always love to hit, or we always get a lot of. What's the largest part that you guys have printed on the studio system?
Okay. The largest part would have been a gear, and it was probably 4 inches in diameter, and I'm going to say 2 to 3 inches high. That's been the largest part we've printed, but we're also a MIM manufacturing house. So typical MIM components are inside the envelope of a business card. So for any customer applications, that's what we looked at. But I mean, in terms of length, I mean, this is probably the largest length part. This is a fairly large part for mass, but we haven't printed anything huge that takes up the whole build platform.
Cool. Another question here: how do you control the quality for small series of parts? And then, is there any sort of typical errors or problems you see, and work to correct those?
Yeah, I mean, for the quality, it all depends on the application. Customer applications, they'll typically, depending on where it's at in that development cycle, a lot of times they'll have a drawing finished, and we'll be able to print the part and check those features to the drawing. We might have to make some changes to the model to account for different shrinkage, but a lot of times we're able to do that, and we control that quality internally.
Awesome. And then, do you have any idea as far as what the kind of payout period for the desktop metal system would be for the business, or is there kind of another angle you're taking on when trying to approach the ROI on the system?
Yeah, I mean, we depending on the technology and what we do, but for the printers, we want the ROI to be in under a year. And I think, by August, by the time we get this, we'll probably be there. So I'm guessing it's going to be right around that 12-month period we'll pay for the machine with internal applications.
And then customer applications goes on top of that.
Yeah, customer applications will be profitability on top of that. Yeah.
Very cool. Another question here: do you find differences in vertical and horizontal direction of the printed part?
Yeah, absolutely. I mean, in the direction of build, you're going to have more surface build layers, and then the surface roughness is a little bit higher on the sides of the part versus the top and the bottom of the part. So yeah, absolutely.
Great. And then as far as let's see if we have any other questions coming in here. What kind of, so this is another thing we get a lot, as far as there's a lot of different things that go into a manufacturing process to create cost calculations and try and, comparing what this would cost manufacturing one way versus manufacturing another way. How do you guys look at that? Does that include everything through, post machining and, consumable materials? Like what, when you say that this one is considerably cheaper to print, what type of things are you considering when you're saying that?
Yeah, our cost model includes everything from material to secondary operations, the labor involved in that, the utility consumptions, the overhead rate on the building. Our cost model is very involved and includes everything. So when we're looking at cost savings, we're looking at the total cost. And something nice about this is it's a huge savings on potential labor. 24-hour manufacturing. We can literally press go and it print overnight while we're not even there. So it's true lights out manufacturing.
Awesome. And then another question we have a couple times here is talking about debind. So typically, I'll say typically for parts what we see is normally about a half a day to a day debind. It depends a lot on the configuration of the parts. So a big block is going to take a lot longer to debind than something that has a lot of different surface areas. So I don't know if you have any experience further than that.
Yeah, it's just like MIM. It's dependent on the cross-sectional area of the part. So if you have a very thick part, this area is going to take longer to debind than this thin area. But you have to have this whole part in the debind for as long as it's going to take for your thickest cross-section. So that's where part design becomes critical. Any coring or webbing you can do is absolutely huge.
Awesome. Another question here. Somebody looking to print things with internal channels where it would be impossible to manually remove the support. So I think we talked about that a little bit earlier with this part. He's asking, can internal channels be printed without supports?
Absolutely, yeah. And it's really a function of how large that channel is. But typically, a round hole can be printed without support. It might go egg shape a little bit during sintering, but typically you will have no issues with printing a round hole without support.
Another question, do you have any known metrics as far as how much time per part you think you spend post-processing these kind of parts?
Depends on the application, but we've done everything from green sanding, which works really well in these parts, to sending them outside to suppliers that specialize in finishing. So again, depending on the application and where that sits, it can be anywhere from, we're able to green sand that day and get into debind and get into sinter, and it doesn't really have any delay in the process, to we have to send it to a supplier and they have a 1 to 2 week lead time to do some type of either mechanical or chemical finishing. So it depends what level of finish we're looking for.
And can you talk a little bit about the differences between those types of finishing, as far as green, any other post-processing versions, things like that?
Yeah, I mean the greens, the wet sanding in green gets you to a surface finish that's fairly high. It's probably pretty close to like a cast surface finish, is what we'd compare it to maybe. And then if you do a combination of the green sanding and sanding it out, you can get to a very high mirror finish, a tool finish. So it's a varying degree.
Let's see. Do you have any? Have you had any info maybe with Metallurgy that you've done on density of these parts and how the density would relate?
Yeah. So it all depends how you print it. If you print a solid part and look at the density, typical density in MIM, you're 95% the theoretical density, 95 to 98. Depending on the alloy, the sintering, what you do. 17.4, our typical process, we're in that 95 to 98 window, depending on the application, the composition of the material. And this seems like it replicates fairly well. Most of what we print has internal structure in it, so actually just doing a density, you're going to get a much lower value. But when we cut off a part, we put it in a helium gas pycnometer, and we're looking at just the density of a small piece. We're in that 95% density range.
Great. Let's see. How have your customers? Actually, I'm not sure if maybe this is more for you guys. How do you look at infill pattern versus thickness of solid, a solid part? How do you look at the two of those, and is there any considerations you make when going between the two?
We haven't had any application where we've printed it solid and had a benefit. We've always used infill because it's such a faster build. You have less material consumption, and like I said, we haven't had anything where we've really looked at a production application where we have to worry about a failure. So I mean, but even for this part, I mean, this is a high stress part, and we print it with infill, and we've had no issues.
Great. So another question we had here is talking about the thickness of each printed layer, and I can actually take a quick stab at that. So we have two different print heads for the printer. So we have our standard print head, and then we have our high resolution print head. For the standard print head, it's adjustable between 150 or 220 microns for the standard print head. And then for the high resolution print head, that goes down to 50 microns. So that high resolution print head really allows you to get super, super fine details. I don't know if you have any experience working with that one at all.
No, we're not using the high resolution head at all. This is all on the standard studio system.
Very cool. So yeah, I mean, even some of these look like pretty tight curves and things like that, but with the high resolution print head, you can get super, super fine detail, which is very cool to see. Let's see. I think that is most of it. We talked a little bit about pre-processing the parts as far as trying to adjust for shrinkages and optimizing supports and things like that. I guess a quick question would be, how does that fit into your workflow as far as pre-processing goes? Is that has that become a new burden that you have to work with, or is it something that kind of is pretty easily flowed into the way that things?
No, I mean for us, it's something that we're familiar with. No MIM launch, everything going in, and very rarely do you hit a home run the first time. And kind of planning out that process flow is something we're familiar with. Something that somebody that's not familiar with it, I mean, the software is extremely helpful with that. So it's been extremely easy to integrate into us. I mean, it's a specific part. I mean, it's 10 minutes of pre-processing, go down through some of the settings. It's not a burden at all. I mean, it's something that's required in manufacturing.
Great. Well, that looks like pretty much all the questions for right now, at least. So I will wrap it up there. Thank you very much for joining us today. Some awesome parts you brought with you, very cool applications, and great to hear that the studio system has really had that impact on your business that you were looking for it to have. And we're excited to have hopefully the same for the production system. So for right now, that's all we have. As I mentioned, these parts, photos and information on them, including cost calculations, materials, things like that, those are all going to be available in a follow-up email to this webinar, as well as on the Desktop Metal Resource Center. So check for that in a day or so once we get these guys photographed and some more details for everybody. But thanks for joining us, Nate, and hope you enjoy the rest of the year with your studio system.
Great, thanks a lot, man.